Before we take a look at more examples on differentiation of trigonometric functions, let's extend a little bit by using chain rule. All right, in earlier part we learned how to differentiate sine x, but now what if you are required to differentiate sine fx? I give you an example. All right, what if I'm required to differentiate sine x squared plus 5? So you use chain rule, you differentiate one time, you get a cosine x squared plus 5, and then your secondary school will say, oh, differentiate the inside, you get 2x. Basically, this one is your f prime x. All right, differentiate one time. So I want to emphasize that this is the one that you is new to you. All right, the equivalent of these two are in MF 27. The equivalent, I say equivalent, means that you are given in MF26, you are given the formula to differentiate cosecant x, not fx, but you should know how to use chain rule to get these two forms. Okay? Yep. So I don't belabor the point. Let's go to some examples. So what if you are required to differentiate these three? Let's do bit by bit. Let's look at part 1. Differentiate cosine pi over 4 minus 3x. So you apply your chain rule. All right. It's differentiate cosine, you actually get a negative sign. Correct? Then you will say differentiate the inside. All right, that is actually your f prime x, which is minus 3. Therefore, final answer is 3 sine pi over 4 minus 3x. All right, part 2. Part 2 requires you to use product rule. I repeat, product rule. Correct? Because you have a product of two functions here. Okay, let's do it very, very slowly. All right, you keep this, you get cosine cube x. You differentiate sine 2x, you will get cosine 2x. But let's bear in mind, you got to differentiate the inside f prime x, you get another 2. All right, plus. All right, you will keep your sine 2x. Yes, then you will differentiate your cosine cube, you get a 3 cosine x. Sorry, cosine square x. Yes, then you will differentiate the inside, which is your cosine x, you will get negative sine x. Then you get negative sine x, like that. Okay? Right, then we simplify. I don't think it's difficult. Simplify, nothing much to simplify. To simplify, 2 cosine cube x cosine 2x minus 3 cosine square x sine x sine 2x. Done. Alright, last one, cosine cube sine 2x. So I want to contrast between part 2 and part 3. Very, very, very crucial. You can see that they look similar, but they are different. They look similar, but they are different. This one is a product rule where you take this multiplied by this. Whereas part 3 here, it is a cosine cube sine 2x. Basically, it is this. If you don't want to be confused, it is cosine sine 2x. It's basically a composite function like that. Oh, sorry, I shouldn't have written it here. Maybe I should just write here. Basically, this one is a cosine sine 2x like that, and then whole thing cube. Alright, and then a whole thing cube. So if you write it like that, then maybe it's a little bit clearer. Then if you want to differentiate it, first thing you do, you bring the 3 down. You get 3 cosine square sine 2x. Yes? Alright. Then what do? You will differentiate a cosine sine 2x. Okay, so if it makes it clearer for you, you do that. So next step is cosine square, 2x. Then you differentiate cosine sine 2x. Basically, therefore, this is your fx. You will get negative sine 2x multiplied by, yes, all right, that you differentiate the inside one time, sine x, you get cosine 2x. And then differentiate one more time, because you differentiate this 2x, you get a 2. So therefore, you have a 2. Many layers of chain rule. You may want to replay the video to see it again, all right, to see what is going on. Therefore, final answer, then you will get this. You multiply everything out, then you get a minus 6 cosine 2x. All right, multiply by a sine 2x. Then multiplied by a cosine square sine 2x. So all these are multiplication. There's not enough space. Maybe you can take a look at the notes at the detailed answer. But basically, that is your final answer. All right. Thank you.